Okay, this is the last assignment of Unit 7 before we get into the reviews. What this assignment is dealing with is the R kind of problems. So as a reminder, R's get bars. Let's go over the formulas and then get started with this assignment. We are asked to find various areas and things like that, but they don't give us an average or a standard deviation. So in the R type of problems, the average, mu, is equal to n times p. The standard deviation is n times p times q rooted. Okay, just as a reminder, q is 1 minus p. All right, so you can get this. What you do is you take this information and you create your z-scores, again, which are x minus mu divided by sigma, then you can get a z-score. From your z-score, you can go down to the z table and you can look up areas. However, these will give you areas to the left. Keep that in mind. And then here is the next most important part about R's. In an R problem, what they do is they give you a value, such as the probability that R is greater than or equal to 7 or something like that. I don't know. Some number, 7. So what you do is you plop down a number 7 on here and you create a bar, aka R's get bars. All right? And then what you do is you focus in on this symbol and you shade what you're supposed to be shading. So the R that I want is greater than or equal to 7. So that is the is greater than and or equal to. Or equal to implies that I shaded the bar. If it was just purely is greater than 7, I wouldn't shade in the bar. Here it's or equal to, so I shade it in. With that, you identify where is that edge between the shaded and the not shaded. I notice that it's just a little bit below the 7. So that would imply that this value is 6.5. If it were a little bit above the 7 on this bar, just above it, that would be 7.5. So it's either a half bigger or half smaller. However, this value is 6.5. And so what you do is you plug that in to your z formula, get your z, and you get your area. However, notice that this area, whatever you look up, is always, always, always giving you the area to the left. So in this particular problem, if I actually had these numbers, what this would do is this would give me an area to the left. Let's say it says this is 0.75 or something like that. Okay? I don't want the area to the left in this case. I want that area of the green shaded region. So this would be a scenario in which I would have to take 1 minus the area to the left, and I would get the area to the right. So that would imply that that would be 0.25. Okay? Sometimes you do want the area to the left, sometimes you don't. That's why it's important to make a picture to identify what problem you're actually solving. Okay, let's go to work. So I need to develop a Q. Again, that's 1 minus P. So in this situation, my Q is 0.66. So I need to find my average, which is n times p. I usually put in the numbers, but so that's 2958. I also need to find my sigma, which is n times p times q square rooted. Let's draw a picture to make sure I understand the question that is being asked of me. So I have this number 35. R's get bars. In this problem, I want the R to be is greater than or equal to. All right, so this puts my edge just a little bit below the 35, so that'd be 34.5. Also note that when I eventually do get my area, it will be giving me the area to the left, which I don't want. So this is a problem that I'll have to do the 1 minus concept at the very end. Let's go ahead and get the z-score of this 34.5. This is a z-score, so I round to the second decimal. And then I go ahead and find the area of all of this mess. So 1.11. So 1.118665. Now, as I said, that is the area to the left of that line that I just looked up, which is, again, is not the area that I want. That's the area that I don't want. So this is a situation where I have to take the entire curve, which is 100%, i.e. 1, minus what I don't want, and that's the 8665. Okay. Number 2. In Mr. Ash's class, only 14% of the students complete their assignments before leaving class. Wow, that's pretty good. So the probability is 14%. That means the probability of not completing that would be 0.86. In Mr. Ashton's second hour class, he has a total of 30 students. Okay, so the average in this case is n times p. Standard deviation is n times p times q rooted. Draw a picture so I make sure I understand the question that is being asked of me. So the average is 4.2. I'm looking for what is the probability that r is greater than or equal to 6. So I create my 6. R's get bars. I want my r to be is greater than or equal to 6. So that's creating the edge right here, which is at 5.5. Okay, now also in this problem, similar to the last one, when I do eventually get an area from this 5.5, it will tell me an area to the left. Again, that is not the area that I want. I want the area of the green. And so this will also be a 1 minus kind of question. So, but to begin that, I do have to find the z-score of it, of this problem. Z-scores, I round to 2 decimal places. So I'm looking up 0.68, 0.68, 7517. In this problem, that is not the area that I want. So to get my answer, what I need to do is I need to adjust it by taking that away from 100%. Okay, notice with these last 3 problems, the n and the p are all the same. So that implies that the q is going to be the same. And so that would mean the average and the standard deviation are going to be the same on all 3 of these problems. They're all a little bit different, but at least the average and the standard deviation are going to be the same. So as soon as I find it once, I can just reuse that information. So the Q in problem number 3 is 0.16. The average is n times p. And the sigma is n times p times q square rooted. All right, so this is going to be the same for all of these problems. So the next problem is going to have an average of 734.16 and a standard deviation of 10.8382. And just go ahead and kind of steal these answers going down the list here. Okay, back to number 3. Let's understand the question that is being asked. That line technically represents 734.16. So I'm looking at the number 720, technically down here. R's get bars. I want this R to be is greater than 720. So I see that the edge of this exists right here, which is at 720.5. Yeah, 720.5. So I begin by turning this into a z-score. notice that that is the area to the left, which is what I don't want. So again, one more time, this is something that I am going to have to take away from 1. Okay, next problem. Same question, but it's going to be or equal to. So here we want is greater than or equal to. That leaves this edge right here, which is a little bit below the 720. So that's going to be 719.5. One. 0885. Note that that is the area to the left. In this situation, that is the area that I don't want. So this is, again, a problem that I'll have to subtract from 1. Okay, last but not least, so I have this number of 720. Again. And we have 761. I am looking for is in between the two things. It is or equal to the 720. It is not or equal to the 761. So the edge exists right here at 719.5 and right here, which exists at 760.5. All right, I did a lot of information about the 719.5. And so that is similar to the previous problem, which came up with a z-score and an area. Okay, I need to do this similar to the 760.5, and then again, find the area in between two things. You take the big minus the small. Excuse me. Hang on, I lost my train of thought. I think it's 2.43. I don't want to make a mistake. Yeah, 2.43. Okay, so the question is, what is the area of that shaded region right there? And so to find that, what I'm going to do is I'm going to take the big minus the small. There it is. notice how that is the area that I want, so I don't have to mess it up. Got to fill in my technicalities. Notice how I am finding, when I get this area, it'll be the area to the left, which is the area that I want, so I don't have to do the -1 thing. One. It is or equal to the 35, and it is also is or is equal to the 40. Oh, let's see here. I know the information about the 40.5. So all I need to do is figure out the 34.5. Okay, now that I have the areas of both of them, to find the area in between, I take the big minus the small.